Hi guys, we are from group AduMekanik. We'll be presenting our engineering programming group project. But first, I will be mention our group member. The first member is Francis Hill, anak Desmondai with metric number of 79462. And the second member is myself, Kenal Jigur, anak Sebeli with metric number of 79762. The third member is Sean Aldo, anak Edward Rugoy with metric number of 81146, and our last member is Sean Fardin, anak Edward Rugoy with the metric number of 81125. And then with all the members have been introduced, let us continue our presentation. So our first slide is our problem statement. This is the engineering problem that we take from our courses, which is the heat transfer. The problem is the water is boiling at 1 atm and the boiler is a horizontally scored copper with a diameter of 30 millimeter. The surface temperature of the rod is maintained at 108 degrees Celsius, so we need to determine the nucleate pool boiling heat transfer coefficient, given the length of the rod is 15 cm.
Next is I'm going to present about the program design. The first program design is the algorithm. The first step is start. The second step is read the surface temperature in degrees Celsius. The third step is calculate the excess temperature by using the formula of T excess equal to T surface minus T saturation. Next is calculate the nucleate boiling heat flux by using this formula. The fourth step is calculate the nucleate boiling heat transfer coefficient by using the formula of H equal to Q boiling divided by the area surface times the T surface minus T saturation. The last step is stop. The pseudocode is more similar to the algorithm, but the pseudocode is the more simpler one.
The next slide is about the flowchart and MATLAB code. Flowchart is the graphical representation of our algorithm. So for the oval shape icon, we use it for the start to start the command, and then using the parallelogram shape, which mean the input of the data, we put the command in read the surface temperature, and then for the processing command, it was represented in a rectangular shape icon. So our first processing is calculate the excess temperature. The second processing is calculate nucleate boiling heat flux, and then the third one of our process is calculate the nucleate pool boiling heat transfer coefficient. And then we end our program by using an oval shape icon again and write a stop command. So move on to the MATLAB code. This first representation is our constant or input that we found for our problem. So we put it in the script files for all of the given data, the properties of the water from the table A9, table 10.1 and 10.3. And then we try to implement the syntax and logical operator and also a function to find our t axis as we see for the second picture of our MATLAB code. So first we trying to put the input command, and then we use a logical operator of if and else if to determine whether the excess temperature is in the category of our boiling types of water. And then after determine the type of the boiling, we use uh, we make a new variable to find our nucleate boiling heat flux. So we put in the formula for it first, and then after that we proceed to the new formula to find the heat transfer coefficient, and then we run it, and then we go to the next slide.
Last but not least is the sample output. The sample output is any information that a program produces. When we run the script file, we enter the value of surface temperature, which is 108 degrees Celsius. And by this value, we get the excess temperature, which is 8 degrees Celsius. From this value, which is 8 degrees Celsius, we can determine the type of pool boiling, which is nucleate. And then we get the pool boiling heat flux, which is 5.0365 exponent 11. And then we get the nucleate pool boiling heat transfer coefficient, which is H equal to 4.4532 exponent 12. And that's all from us. Thank you for listening.